Alright, for this next part, the directions say tell whether the function is quadratic and explain. I think one of the easiest ways, there are other ways to figure out if something is a quadratic or not. You can look for the second difference. But honestly, I think you guys will find it easier just to go ahead and graph it. So you get -2, -9, -1, -2, 0, -1. You've got 1, 0, and you've got 2, 7. You can see this is not a quadratic. It does not make a U or a hill, which is what a parabola would make. We need this type of shape for it to be quadratic, one of these two. The next one, to tell whether or not something is a quadratic function, we'll just go ahead and graph these points that are given. -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. Notice what I get is the parabola shape, so this is a quadratic because I do get the parabola shape. The next part, it does not give me a picture anymore of what, does not give me a picture or points to go off of. I could create points, or I can remember what I learned earlier, that a quadratic function is in the form of y equals ax squared plus bx plus c. As long as I have this x squared term, I know it's a quadratic. Otherwise, it's not. This does not have an x squared term, so this is not a quadratic. This happens to be a linear function. Okay, so you can say the reason is no x squared term. On my next example, if I look at this, I could put it in that typical ax plus bx, ax squared plus bx squared, or excuse me, I keep saying it wrong, ax squared plus, there is no bx, plus c, to see whether or not it's quadratic. But I really don't even need to do that necessarily because there is only one x squared term, and since there is an x squared term, it is a quadratic. So this is a quadratic because there is an x squared term. Another example of that, again, it's very simple, that this is a quadratic, and the reason again is that there is an x squared term. Alright, for my next example, it says, use a table of values to graph the quadratic functions. And then it asks some other questions. So what can I pick for x's? Well, I've already went ahead. I always make sure I pick some negative and some positive values. I try to just go in order to make sure I'm going to get that U shape. So this one, when we plug it in, we have to be very careful though, because it says -4 times -2 squared. So the -2 is being squared, okay, which gives me a 4, but then I'm still multiplying by a -4. So my actual y value happens to be a -16. So then when I go to plug in the -1, I have y equals -4 times -1 squared. Well, the -1 is being squared, but I'm still multiplying by -4. So -4 times 1 is -4. Then when I plug in 0, I just get 0. When I plug in the 1, I have y equals -4 times 1 squared. Okay, well that ends up being a 1, and then times -4 is -4. And the same thing occurs when I plug in my 2. I'll end up with the same answer up here as -16. So I'll graph these points. -2, -16 is way down here. -1, -4 is right here. 0, 0, 1, -4 is here, and 2, -16 is way below. Okay, so what is the domain? I may have to do that on the next video, but I will go and address the vertex. This is the vertex. The vertex is its highest or lowest point of the parabola, and the vertex on this problem happens to be 0, 0. I'll continue this on the next video.